All right, welcome to another episode of Nukes of Hazard. I'm Sarah Bradley.
I'm Mike Bradley.
Rod Whelan.
Susanna Whelan.
And today we have a very, very special guest with us, Jon Greives, who's the acting director of the Division of Advanced and Non-Power Reactors for the U.S. Nuclear Regulatory Commission. Jon, what a mouthful. It is great to have you. Thanks for being here.
Yeah, thanks for having me. Really excited.
Excellent. So in today's episode, we're going to have a great conversation with Jon, talk about what's new at the NRC. But then before we get into that, we want to talk about some of the great things that are happening in the news, both at the U.S. level, but then also overseas, Japan and Africa, I believe.
Yeah.
So Rob, will kick it over to you for the news.
Multi-continental. So some big news this past week. Japan committed to investing a lot of money into heavy industry in the United States, $332 billion of it into nuclear. You probably heard $550 billion. And interestingly, it's already been kind of carved up. So $100 billion, I'll give us some highlights. So $100 billion to Westinghouse to build AP1000. So these are the two reactors that were built in Vogtle at the Vogtle plant in Georgia. And they'll get some partnerships with Japanese companies. Another $100 billion to build small modular reactors. A couple are going to be up in Canada. And then it kind of goes down the line. And this is significant because the United States government has not always, has never been in the business of financing or providing financing. There's been loans, but to actually provide the financing for nuclear is significant. And these are big numbers. You can probably build, I'm hearing about 8 AP1000s with $100 billion. So that's a big one.
No, Rob, when you were at GE, was the partnership with Hitachi there, or did that come after you left?
It was there. And that might actually be some of the, now it's been split. It's now GE Vernova Hitachi. And we had a loan from the Department of Energy that we were operating under. It was $100 million a year. And we were designing the ESBWR, a mega reactor, which got certified but never built.
Okay. Yeah. I mean, growing up, there were these two big companies, General Electric and Hitachi, and then sometime when we started going underwater, they must have developed a relationship. And but yeah, so now GE Hitachi has been at the forefront of a lot of the nuclear technology and nuclear development. I believe Steve Long, they have a relationship. Wilmington is seemingly a nuclear hotbed because of the GE Hitachi presence there. But no, but this is really cool, and the way it's broken down to give different stuff. SoftBank is a big financial company, but I think it has a lot to do with like some of the technology and I want to say video games, to be honest, that are developed in Japan. So it's kind of cool that all of these different companies are involved in this financing. So
yeah, certainly those are two of the stalwarts in nuclear between Westinghouse and GVH. The entire operating fleet generally gets fit into two buckets. Either it's a Westinghouse design or a GE design. There are a couple other designs out there, but that's the current fleet. And then these are obviously the next generation, the Gen 4, Gen 3 plus designs that are significantly more improved than the operating fleet. Although certainly from a safety perspective that have some enhanced safety margins. And so there's some exciting stuff going on. The Westinghouse for the AP1000, certainly we have some experience in the US for building them, which is going to lend itself hopefully to bringing down, cost, but it also helps us from the NRC side in doing licensing. And we've been doing a lot of collaboration with our international counterparts like Japan. The second bullet there mentions, such as the SMRs, such as the BWX 300. So they're currently GVH is working with at the Darlington station. The OPG is building a BWX 300 design there. And we've been working with them for years now, collaborating with Canada to do, because we knew that GE wanted to then build them in the US. So how can we learn from each other? How can we share resources and share, expertise? So a lot of collaboration going on with our international counterparts too. But yeah, definitely exciting. Looking forward to seeing the applications come in.
No, yeah. You use some like Rob and I and the ladies are trying to pick up this nuke terminology there. You said Gen 4 and Gen 3 plus.
Yep.
Can you just give a quick overview? Is Gen 1 like AP1000? Is that Gen 1 or is that?
No, AP1000 would probably be more like a Gen 3 or Gen 3 plus design. I mean, there are a lot of enhanced safety features, and AP1000 is a large pressurized water reactor, but it's has a number of enhanced safety features like, passive cooling and things like that. Gen 4, you're getting to a lot more advanced designs where you really limit the amount of operator actions you might need. You limit, your safety case is really built up from a past. So if you compare it, let's talk, maybe like the current operating fleet, you're talking more like a Gen 2 or maybe even some of the newer ones into a Gen 3, where it's very large, active cooled systems, not all, that dissimilar from what we operated in the Navy, from a nuclear physics standpoint. But because these large active, systems, you need operators to operate the plant that are really important to the safety case to make sure that it shuts down safely and all the safety systems function. Whereas the new designs, what you're starting to see is they're bringing in they're going to smaller designs, right, to hopefully improve manufacturability of them, which improves just the cost projections. At least that's what the industry's hoping for. But it also allows them to bring in features like completely passively cooled. They can look at new fuels that are more accident tolerant, or accident resistant. So there's a lot of new features that can come in with these later designs.
That's cool. So with your title being advanced technology, you're mostly dealing with Gen 4 stuff?
Yeah, yes, but I'll say it's even a little bit more than that. So my division does all of the new reactor licensing stuff for non-light water reactor design. So everything that we've dealt with, historic, not really everything we've dealt with. We have had non-light water designs, but generally in the original, as plants were being rolled out in the 50s, 60s, 70s, they were, the U.S. ended up settling on light water reactor designs, right? So it's water cooled, water moderated designs, and that became what the U.S. Kind of put all of our investment into, and that's what the 90 plus plants that are currently operating across the United States. They're all light water reactor designs. What we're seeing now come in is interest in non-light water reactor design. So the two that were mentioned in that news article, those are both still light water designs. One's a pressurized water reactor, one's a boiling water reactor. But we're seeing a lot of new designs that are featuring, are either high temperature gas reactors, sodium cooled, fast reactors, a bunch of different designs. A lot of the micro reactors, which are in the news right now, are non-light water designs. It's just a different technology, offers different features, really up to, the use case. They offer new use cases, which we can talk about, in a little bit, but certainly some interesting things for us to think about, as well as the industry.
Very cool. While we jump continents with the news, Rob, where do we go next?
Let's talk about the Department of Energy now. So John works at the NRC. It is completely independent from the Department of Energy, but they do work together on occasion. So, but the two entities signed a memorandum of understanding that essentially helps these. There's this kind of race to get critical by July 4th of next year. And this came out of some executive orders from May. And basically there's 10 companies and they're like, well, we're going to work with the DOE. We're going to run these reactors. We're going to get a lot of safety data. We have to follow the DOE's regulations to get them running. But what happens when we go talk to the NRC? Because the NRC that license will allow us to sell the electricity to the public. Do we have to start over is what they've been asking. And what these two agencies did is they said, and I'm going to mangle this a little bit. You can correct me, John, but basically saying the stuff that you've gone through with the DOE, we at the NRC are not going to revisit unless you've changed your design. So basically, and the safety standards I would suspect are somewhat similar. There's different procedures, but basically the NRC is saying you're not going to have any gotchas if the DOE has already looked at it. So that's significant for people. And I know that some of these companies have invited the NRC to kind of observe. I don't know how that works, but they want to make sure that the transition from this test bed to like commercial operation is seamless. Do I have that right, John?
Yeah, I think so. I mean, so we definitely have different regulatory structures. Like you mentioned, the NRC generally regulates commercial power plants. So just the entire commercial side. DOE has authority under legislation to be able to license test reactors, right? That they own and operate. But none of these companies are in the business of building test reactors. They want to be able to commercialize these reactors. They want to be able to make money off of them. So there was always a natural progression. We've actually been working with the MOU that you just mentioned was really the ninth addendum to an MOU that we put in place back in 2019 as a response to something, legal term, everybody loves acronyms, but it was the NECA, which is the Nuclear Energy Innovation and Capabilities Act that Congress signed into law in 2019. And since then, we've had a whole bunch of MOUs that have continued to expand our collaboration and work with DOE. This one in particular came out of, there were a series of executive orders that were issued in May, really looking to revive and the government support for nuclear and make sure that we're all working towards, this kind of foundational, get nuclear back, off the ground and into production. And one of them, so like you mentioned, there's a couple of them. DOE had one that said, like you mentioned, they wanted to see, the executive order wanted to see DOE license and have some reactors go critical. We also had an MOU. One of them was to talk that, specifically talked about a streamlined licensing pathway. I mean, ultimately, the companies will eventually have to meet NRC standards for, safety and ensuring that they're putting out a safe reactor. But like you said, I mean, there's a lot of work that they do to demonstrate that a new technology is safe and is going to function safely. And that can be done in a test environment like they would for DOE. So, dating back for, we've been working heavily with them, probably almost a year now, specific to this particular topic. It's really ramped up since those executive orders and ultimately culminated in signing the MOU that laid the framework for how are we going to collaborate as you license these new technologies and as companies want to then, transition them into commercial licenses in the future. So, we do something, and we could probably talk about this later, but we have a term where we call delta review, where we say, hey, what's different? If something has been, and we'll do this even internally, and we have some specific examples where if we license a technology and then they want to deploy it a second time, hey, why don't we focus on what the deltas are? What's different between this application? It might be where it's located. That can have some certain differences where you got to think about, hey, maybe hurricane is a something we need to think about to make sure it can be safe following a hurricane if we're building it on the Texas Gulf Coast. But if I'm building it in Kemmerer, Wyoming, maybe that's not the external hazard I need to think about. So those would be some differences. Maybe the technologies are different, right? So maybe they've scaled it up. A lot of the DOE test reactors might be scaled versions of their commercial reactor. So we need to think about hey, what new risks are posed by the fact that it's larger. We may also need to just think about, how it's going to be operated and the construct that DOE is able to operate in, whereas a commercial reactor might not have the infrastructure that DOE can provide. So we can focus on those deltas. They still ultimately have to show and get a license from the NRC. But it's ultimately just thinking about how can we do that efficiently while really not compromising any safety standards.
Yeah.
So the test reactors that are going to be built at Idaho National Lab, conceivably by July 4th, some of those approvals and processes that DOE does, you'll be able to take that and apply it to NRC approval processes, conceivably.
Conceivably, yeah, potentially that's what we would, like to do. And I think, if you're, you know, if I were a developer, let me say it this way. If I were a developer,
Can you go
I
on
wanna,
record, John?
yeah, right.
For the
I,
NRC?
and this, and yeah, I was gonna, absolutely not. This is me in my personal capacity. But no,
Breaking news.
yeah, that's right. If I were a developer, I would, say I want to think about with the endpoint in mind, right? So if I do want to commercialize, then I want to understand what the NRC's regulatory infrastructure is. And we've been working with, pretty much every one of those companies that the DOE announced. We've been working with for some time, each and every one of them at varying degrees, where so that they can understand the regulatory infrastructure, what the regulations look like, what an application would look like, and then can work with DOE to say, well, what are the deltas? We've been working. One of the things we've been, that's in that MOU or discussed is making sure we understand the deltas between our regulatory frameworks, right? Because there are some deltas, like you mentioned, but there's a whole lot of similarities too, right? And so, do we understand? And then can we communicate that to the developers of, okay, well, here's what it takes to get a DOE license. Here's what it takes to get an NRC license. So now you can imagine that Venn diagram of what those two things look like. And is there a way to expand the overlap as much as possible and really make sure that, we can both align on the overlap, that that's a safe approach, but then really focus on, what are the deltas there and put our resources there.
No, it's cool. That's cool.
So do we have time to go to Africa?
Let's go to Africa real quick. Yeah.
All right.
Yeah.
Let's do it.
The idea here is, okay, there's kind of a trend. We're seeing these plants get license extensions. It's a sort of an event. We've seen a few of them in the United States. We wanted to bring this up to John, not because the NRC has necessarily worked with South Africa, but the NRC has worked with foreign governments and their regulatory bodies here and there, and also has done license extensions. John, I don't know if you know, actually, I think you said you don't know much about this one, but
Yeah.
what's a license extension and why is this significant? And how does the NRC work with foreign governments when they have the opportunity?
Yeah, So the way that currently in our regulatory, like for the United States, I'll speak to that, and I think a lot of countries are similar, is there's an initial license length. So when you issue initial license, ours is 40 years. So a commercial reactor can be licensed by law, can only be up to 40 years. And then after that, you can extend that license on increments of 20 years for, pretty much every plant in the US has been extended from that 40 to 60 years. There's been a handful of plants that have been further extended from 60 to 80 years. And really what you're thinking about there is the nuclear physics hasn't changed, but the life of the plant has. So you're looking at material degradation, passive components, things like that to make sure that it's going to last for the next 20 years. So, that's what that news article was about was, the South Africa had extended the license. We do a lot of collaboration. Typically IAEA is the international body that kind of governs and sets standards internationally. And we participate, fully with a lot of IAEA activities, and then also work individually or collaboratively with different governments. So we have like a memorandum of cooperation with Canada and the UK to work on some specific designs. We mentioned in the first article we talked about the work we've been doing with them on the BWRX 300 design. That's the GVH's design that they're deploying at Darlington, and we are currently have an application in review for that technology to be deployed in Tennessee, and so we can like work with each other to understand. Now, every country's regulatory structure may be different, right? Might have different legal frameworks, might have different, but the nuclear physics really isn't different, right? So the technology, the how can we leverage, our expertise can help, and then we can also work with each other to say, hey, how do you do this process, right? How do you do license renewal? Okay, well, this is how we do it, and then we can, look for lessons learned to figure out how we can do it more efficiently. I think every government out there wants to do things, more efficiently. Ideally, you'd hope that's the case. Certainly in the United States, we want to do that. So what can we learn from our foreign counterparts? What lessons can we apply to how we might do things differently? I think one of the things we're certainly proud of is I do think the NRC is kind of the gold standard internationally for how things are regulated. And so that allows us, I think, has a number of countries that want to collaborate with us to see what we're doing, and how they might leverage what we're doing, particularly, developing countries that are trying to get a new nuclear, a nuclear program started up, but even, existing, but there's a whole lot of, learnings that we share back and forth in a variety of different working groups and international activities. Yeah.
In the Nukes to Hazard power balance, Rob's more the software guy, the whatever. I'm more the heat transfer, water, whatever. When you're getting extensions on the reactor, what what do you think would be the thing that you'd have to worry about the most? Is it the actual vessel? Is it some of um the pumps, the water flow, things like that, or is it more the safety features, the more the electronics, more the computer systems, the safety systems? What do you think would be the thing that we would, because over 40 years of technology, some of your safety systems that are based on computers and whatever, it's all going to be changing.
Yeah. Yeah, I mean, I think so. When it comes to license renewal, generally we're focused on passive sort of stuff, so pipes, vessels, and things like that, making sure that welds are going to last. What's their inspection program? The NRC, we have something called aging management programs, AMPs. You might hear them, and so that's just how are they managing these? What program do they have in place to be able to monitor aging? Pumps are kind of easy because you can take a lot of data and you can put sensors on pumps, flow, vibration, temperatures, all that stuff, and you can monitor it real time, right? And now with AI and different, you can really analyze and understand and predict. So there's been a lot of work in the industry to think about, prediction of understanding how a pump or a valve is performing. Passive components are a little bit harder, right? There are still ways to monitor it, but it's not something you're necessarily able to monitor real time in all cases. So what do those programs look like? But so I will say, something that the industry has been looking at for quite a while is obsolescence. I mean, the systems that were designed, I mean, these were designed in the 50s and 60s, and they work really well, right? And they're very reliable. But at some point, it's hard to find replacement parts. It's hard to find, you want to upgrade the digital control system. So we've been spending some time thinking about, what does that look like, and how can, is our infrastructure set up to be able to license that? If somebody wanted to completely change over their control system to a digital system, that sort of thing. So there are some plants out there looking at doing that. Wouldn't necessarily be license renewal. That'd be just more of a change that they need to look at. But, I think there's definitely some interesting questions out there as they go from, 40 to 60 to 80 years.
Oh yeah, no, definitely.
Well, I think we've kind of already touched on your career a bit, John.
Yeah.
Love to dive deeper in. Usually when we have our guests, we ask them to tell us about their journey from where you started to how you got to where you are. From Baltimore, Maryland, to where you are now. So do you want to give us a quick bio? How did you get into nuclear power?
Yeah. So, appreciate that. So yeah, I grew up in Baltimore, Maryland. Didn't really, know what I wanted to do. Went to college like anybody. I went to Bucknell University, was an electrical engineering major. But when I was, in school, I was kind of like, hey, I didn't really know what I wanted to do when I grow up. I sometimes think I'm still not sure what I want to do when I grow up, right? But
Yeah.
so we had a recruiter come into class and pitch this Navy nuke program, NUPOC, the nuclear propulsion, NUPOC, what does it stand for? Yeah, Nuclear Propulsion Officer Candidate Program. And would let you, kind of join. It would throw you some money while you were at college, and I didn't know what I wanted to do after college. Had a number of family members that served, and so that was always intriguing to me. Certainly growing up in Baltimore, so close to Annapolis, the Navy was something that was of interest. And so I took the plunge, did that. That's where I met, Mike initially, right? We were in and sat a row apart at Power School, went through Power School and prototype. And again, electrical engineer, I didn't know very much at all about nuclear, but the Navy kind of trained me up. Went after my sea tour, being on the sub. I went back and taught at prototype and Power School. So I got to do a little bit of a longer shore tour. but really kind of firmed up my kind of love of nuclear. And then, as we were deciding to transition out, just started a family. It was right around the financial, because of my longer short tour. I think I was a little bit after, as the financial crisis and a lot of the jobs were drying up, particularly in nuclear. It's like, okay, well, maybe job security is a good thing. I was always drawn to public service. So I decided to stay with the NRC, or I decided to join the NRC. Sorry, that was in like 2009. I actually joined into one of our regional offices. So the NRC has 4 regional offices. One's in King of Prussia, outside of Philadelphia. Being from Baltimore, my wife is from Allentown, and Philly was kind of right between the two of those. It made a lot of sense as we were starting a family. So we moved there, and I joined in what's called our resident inspector program. So every operating power plant in the country right now has at least 2 resident inspectors stationed at it. So those are folks that go to that power plant every day. They work remotely from the NRC office at the power plant, and they're kind of the eyes and the ears, boots on the ground, whatever colloquialism you want to use. So I joined that program, moved up to Northeast Pennsylvania to a power plant up there, and spent my, about 7 years as the senior resident inspector there. After I finished up, came back into the region as a manager, managing those resident inspectors at a few of the different plants, and then kind of got the itch to do something different. Got a call from somebody, got an opportunity to work in our, the division that I'm currently in as a deputy director, and then more recently moved into an acting director role, as we've had some kind of transitions where we do a lot more of the licensing of kind of the new reactor stuff. So, that's kind of my career in a nutshell. Certainly an exciting time to be in nuclear. I certainly wouldn't have thought I would have been in nuclear, and I definitely wouldn't have thought I would have been in nuclear as long as I have. But it's been long enough, interestingly, to see really what looks like a very promising renaissance for the country of nuclear coming back. So it's definitely an exciting time to be in nuclear, and so just certainly happy with where I've ended up and what I've been able to do.
No, that's super cool. Suze, you had some question you want to ask?
Yeah, I was gonna say, just on the heels of you saying that this is an exciting time and that kind of renaissance of the nuclear prototypes that are coming in, and this agreement, the things that Trump signed back in the summer, wanting to fast track some of these new designs, and this MOU that we were just talking about, kind of put you right directly in the center.
Yeah.
All of this.
Yep.
I'm really interested in knowing, for you, what does success look like for the NRC looking forward in the next 2, 5, and 10 years? What would you
Okay.
see?
Yeah, so I would certainly say, I'll start short term. So in the next 2 years, I'd expect, one, the NRC's going to look specifically at our organizational structure to make sure that we got the right organizational structure to set ourselves up for the future. So we're working towards, do we have the right setup, the right people? So we're going to spend quite a bit of time, I think, thinking about workforce. That's probably our biggest challenge right now, to be completely honest. Mainly because there's a lot of companies out there that are hiring, right? And so there's a lot of competition, which isn't a bad thing, right? I mean, that makes us all try and work a little bit harder. But so I would say, in the next couple of years, it's making sure that we're, one, getting any applications that are in-house, licensed and issued on time, under budget. We've been successful at that so far in the last, certainly since I've been in this division, but even predating that. Have had a number of construction permits and combined, and license applications that are currently in-house. We're all projecting to finish them on time and under budget. So that'll continue to be kind of the success, measure of success. And then setting ourselves, looking a little bit further, so I would say over the next couple of years, we're going to see, maybe a dozen or so applications coming in. Some will be potentially leveraging DOE, but some are just coming right to the NRC because they're ready to do that. And so we'll be ready and have the right folks in place to be able to handle those applications. Looking out a little bit further, you'd expect the number of applications to then continue to grow, right? What that probably doesn't mean is, we might need to grow a little bit, but we're not going to be able to grow at the pace that the number of applications are going to grow. So what are we going to do differently to make sure we're prepared for that? So we're looking specifically at how we could leverage AI to make sure that we can kind of multiply our workforce through, digital means. Still need to have smart people that are looking, over the shoulder and checking all the work. But, how can we really focus our efforts on the things that are most risk significant? Would expect in the 5 to that 10-year range, a lot of those applications to become what we'll call nth of a kind. So a first of a kind application, everything's new, right? It's a new technology. It's a new application. It's a new location. So we're looking at everything and you're diving deep into it. But then as a company progresses into nth of a kind, you really can think about what are the deltas. And so how can we leverage digital tools? How can we leverage the workforce we have to kind of deal with that exponential growth in applications we would expect? I think that's really what I would say, success looks like for us, is being prepared so that we are definitely not the long pole in the tent. We're not holding the industry back. We're there to support. And I will say, one thing to kind of highlight it, we just had a pretty significant change late last year where we updated our mission. The NRC's mission was always safety, right? Safe and secure use of radioactive materials in a variety of settings. But what we did, and this was in response to the Advance Act last year, was update our mission statement to say, well, how do we do that? We do it by, enabling new technologies through efficient and effective licensing, right? So we started bringing in this enabling and efficiency language that may have been there in certain parts of the agency, but now it's really enabled a kind of a cultural shift to make sure that we're there to support, that getting these new technologies deployed.
Quick follow-up to that is, how many are on your staff today, right, working directly under you?
Working directly under me, we have so our division is about a little over 100 staff working under me, and that's, like I said, our division does all of the non-light water reactor licensing. We also do all of the new as well as operating reactor licensing and oversight for non-power reactors, which are research and test reactors. So there's a handful of college campuses that have a research reactor, just like at Penn State or things like that. That they use to train, or to do, research and development activities. We do all the licensing work for that. The sister division, called the Division of New and Renewed Licenses, that does all the light water reactor licensing. And they, they're a little bit smaller than us, but still a pretty large, division as well. Overall, the NRC has about maybe 2,900, maybe 3,000 staff, total right now, which is quite a bit smaller. I mean, when I joined the NRC in 2009, we were about 4,000. That was on the heels of the original nuclear renaissance, right? So when we were getting out, there was going to be a new nuclear renaissance, and then there was the oil and gas boom. The fracking became a big thing, and that kind of took the floor out from under that renaissance. And that's why we only ended up with 2 plants, the Vogel, 3 and 4 being built. So as part of that, the NRC had scaled up to be able to handle Renaissance 1.0. And we scaled all the way up to almost 4,000 staff. And then when it didn't materialize, over a number of years, scaled down to where we are right now. So when you asked, Susanna, about 2 to 5, and I talked specifically about organization, and I talked specifically about how are we going to handle an exponential growth in licenses without growing our staff back, because we need to be smarter about putting resources where we need them, making sure we got the right people, right, to make the right decisions. But it doesn't necessarily have to be done with just brute force of just add people, because then you can end up in a place where you don't necessarily want to be, where you don't need them, and then and that's not a very good place to be either.
Speaking of natural gas, ironically, some of the small modular reactors who want to supply data centers are now looking at natural gas as a bridge power supply for the X years, 3 to 5 years before theirs are online. So, okay, so you've got the sister division, light water, and yours is non-light water.
Yep.
How do you divide up the workload? Because all these designs are so different. That's unique about this era. A lot of innovations on fuel type, moderator. So what's that like for your staff, and how do you how do you advise them on how to split up the work and approach this stuff?
Yeah, so it's certainly a challenge. There's a few things we've done, and this dates back to about 2017. We put together what's called a vision and strategy document for advanced reactors in the future, and it said, hey, what do we need to do in the NRC to really think ahead and prepare ourselves for this, kind of the new renaissance, these new technologies. And it involved a whole lot of things: hiring, training, knowledge management, knowledge transfer. It also had a lot of upgrades to our regulations and guidance and things like that to the staff. And we've been, based on that 2017, 2018, have been continuing to upgrade and prepare ourselves. We also do a lot of engagement with developers in what we call pre-application engagement. So that the only time a developer is required to engage with us is if they want a license, right? And then they submit an application, we review an application. But I think pretty early, as part of that vision and strategy, we said, you know what, we really need to start working with these companies ahead of that, right? So that we understand what's coming down the pike, so that they can prepare, right? And they can be prepared to submit that license. And oh, by the way, if we do that and we do this pre-application, then it should shrink the amount of time and the amount of resources to do the license review. So we've been engaging with dozens of vendors since then, as and that's from the Westinghouses and the GBHs to much smaller companies like Radiant or an Oklo that are building a much smaller micro or small modular reactor. That whole range, to make sure we understand what are your business models, how do they relate, or how will our regulatory pathways match up with it. And so based on that, we've done, like I said, a lot of rulemaking, a lot of guidance development to make sure that we're prepared for it, trying to make staffing and like I said, the workforce and knowledge management is certainly a challenge, trying to make sure that we understand where the needs are, and are we developing staff to be fungible to where they can work in different areas. Ultimately, and understanding the commonalities. Ultimately, whether it's a material going into a metal that's being used in a light water or a non-light water, there's still a lot of overlap, right? So we can still use that expertise, but certainly we need to develop and hire specialized expertise that may apply to a particular design.
Do you have procedures for sodium cooled reactors? Do you have to make that up from scratch?
Yeah, so the regulatory infrastructure. So it's interesting. That's a really good question. So our regulations have grown or have been developed over the years and have been solely a light water reactor focus. So part of that vision and strategy was, okay, well, what do we do with our regulations? Because they're currently set up, they're very light water reactor centric, and they're also what we call deterministic. They're not risk informed, from the outset, right? So it did require a lot of thinking, creative thinking, for how do we manage that? How do we manage it on the near term before with the current rules, through either using exemptions or alternatives or reliefs? But then what rulemakings can we have to put together a more technology inclusive framework? So we currently have a rulemaking that's been going on for a few years now and is nearing the final push to get that out on the street, called Part 53, which is a new licensing pathway that's truly a technology neutral framework. Any technology can be licensed under that. It's risk informed and performance based, which makes it a lot more flexible for a developer. Lets these new ones that have all those new features that we talked about from the outset, right? Like the passive cooling, no operator actions, new fuels, lets them really then use that framework to afford themselves a lot more flexibility. And then we have some additional rulemakings going on. You mentioned the executive orders from President Trump earlier. That's kicked off some additional activities to have us do a whole scale, relook at our regulatory infrastructure to make sure that we're set up for the future for all the variety of technologies. So that includes some rulemaking that we have going on to look at micro reactors. These are really small. If you compare the two of them, the current operating fleet, we're talking gigawatt sized power plants, right? So 1,000 megawatt power plants compared to a micro reactor, which might be 1 megawatt, right? I shouldn't have the same rules in place for both of those. They're different risk sets. it's different risk to the public. And so we should be able to have a tailored or a framework that's specific to those new designs. So we've been looking specifically at that. There's going to be some things coming out next year that I think will be really interesting for the industry to see, and we're really excited to be able to kind of move the needle in what our infrastructure looks like. But yeah, so we've been able to adapt our current framework. So we're currently, for example, licensing or going to be doing a review on a construction permit for a sodium fast reactor in Kemmerer, Wyoming. We've been able to adapt our current rules so that we can use it with that. But in the future, we'll have new rules in place that'll make it a little bit more flexible and a little bit easier, kind of built from the ground up.
No, that's so. I was on your website today, which the NRC website's actually really good to go through and try to learn about some of these. And I'm going to put a chart linked in the show notes here about all the different advanced reactor designs: the high temperature gas reactor, light water reactors, molten salt fast reactors, sodium cooled reactors, and then some of the other ones. And we all have children and we all have our favorite child. So Jon, do you have your one that you enjoy, at least like reviewing the technology the most, or it's like most interesting to you? Or I don't want to say it's like most likely to get approved or anything, not anything that like puts the NRC out there, but is there one that you think is kind of like more interesting or I mean, just take it from there?
Yeah, no, so
Bye, Suze.
so what I would say is you're right. I'm not going to pick a favorite child, right? So you're not going to force me into that, like,
okay, go ahead.
But I will tell you, I think there's a lot. I think all the new stuff, particularly the non-light water. I mean, growing up in nuclear, when we did the Navy thing, we had pressurized water reactors, and it was light water reactor designs. Once I got to the NRC, I started learning about a boiling water reactor, very different design, but still light water. Now I'm doing non-light water stuff, and I'm starting to see, man, there's some different use cases where if I don't just want to have power, if my need isn't just power, maybe I need process heat. I got some different applications. Microreactors, I think, are really fascinating to me, and I'm really curious to see how microreactors are going to play out in the market, because they offer the ability to deploy to really remote areas, disaster relief, things that, I think are really important, where how can nuclear play a role? Is there an alternative to trucking a diesel engine out to somewhere like that? So yeah, I think all the technologies are really interesting. I think it's really, what are the use cases where I see being pretty fascinating to see how they may deploy.
Yeah, I heard like the desalinization aspect and like getting fresh water to places that can't get it. It's super awesome. So
Jon Greives not going to pick a favorite child. I like that about you.
Yeah.
You have a beautiful family. It's nice.
I'm glad you got Carrie and Caitlin in the video. Yes.
Yeah.
We are just about at time. Any final thoughts, Rob, Mike? Any last questions
No.
for Jon?
Just so thankful you could come on here, buddy.
Yeah,
So,
Jon.
And hey, stump for the NRC. If you're like a lot of my nukes watch these videos, Jon has had an amazing career, a pretty darn good work-life balance. Over the NRC is going to need to be hiring, and it's a really good place to work if you and it's something that you were able to take your time and buy back your Navy time, and so there's a lot of really good benefits to working for the NRC, and you're making us proud, Jon. We appreciate it, buddy.
Yeah, thanks. I agree with you. I think sometimes working for the government gets a bad rap, but I'll tell you, it's been really fun, a really good journey. Every person at the NRC is super connected to the NRC's mission, even after, as it's changed. I think that's allowed people to connect even more. There's no better, same thing when we were in the Navy, right? We were always very, very focused on what we were doing, right? We were, whether you were on a fast boat, a boomer, or you were on a carrier, you knew how running that power plant was connected to the mission. I think anybody that works for the NRC can also connect with that too. And then you add in all the fringe benefits. You're right. The idea of being able to buy back your military time, so I didn't have to start from scratch. The work-life balance, being able to have job security. I think even I will say, like, if you look at the executive orders, right, mean, it specifically said that there's likely potentially growth in a lot of areas in the NRC because of all this. So I certainly have felt secure in my job and wanting to continue it. It's pretty exciting. So without a doubt, anybody hit me up. I'm sure, we'll be hiring.
All right, Jon Greives with the Nuclear Regulatory Commission. Thank you so much. And thanks to our listeners, to the Nukes of Hazard. Till next time, we'll see you all later.